All right, guys, so this video is going to have videos or problems 21 through 25. Let's go ahead and get started. We have f of x is equal to the following function. Okay, so this is the machine, if you will. And I'm going to build it real quick, waiting for that input of x. And in this problem, we're being asked to find what is 3 times f of 2. So this is what this is asking right here. So let's go ahead and find f of 2 first, and whatever we get, we're going to end up multiplying by 3, and then we'll be done. So f of 2. We're going to use this function, and we're going to put 2 in where x goes. That's what f of 2 is looking for. So negative 5 times 2 is a negative 10. We're going to add 7. So f of 2 is equal to a negative 10 plus 7, which is a negative 3. So just like on the test, we're going to write it like the following. Okay, so f of 2 is equal to negative 3 will be the answer just for that piece, okay, but not for the complete piece, okay? So this is f of 2 being negative 3. So what we're going to do is we're going to multiply that by this 3 right here. So we still have this 3 that we're multiplying by the original problem. So this equals negative 9, okay? So again, we're not just going to put negative 9. We're going to put what it's equal to, which was the original 3 times f of 2. And then we get that answer right there. Okay, so again, put 2 in where x goes. We get negative 10 plus 7 is negative 3. We multiply with 3. We get negative 9. Let's go to 22. It says, use set notation to write the domain and range of the function shown in the graph. Okay, so this is our graph. And remember, like I said before, if nothing's shown as far as being an endpoint, you're to interpret by default these arrows that go off basically to infinity. So as you go to the right, it will go down. As you go to the left, it will go down infinitely. Okay. So again, set notation. So let's go ahead and set up our set notation for both the domain and range. So the set of all x's such that, and then we have conditions, and the set of all y's such that, and then we'll have our conditions. So a reminder, when you're doing set notation, these pieces are going to be in algebraic form, okay? That's with the less than or equal to or greater than or equal to and stuff like that. So don't put brackets or parentheses because that's interval notation. We don't want to do that for this particular one because we're wanting to use set notation. All right, so if I were to scan this with a vertical line moving from left to right, like I said, this will go on forever. It's not like one of those vertical asymptote questions that was in like 16 through 20. This one will slowly go to the left forever, but it's going down also. But nonetheless, it will go on forever to the left. So it's going to be like a negative infinity to a positive infinity fill to it, okay? But again, we're not putting it in interval notation. So I'm going to come over here where I built this set notation. I only use the interval just to get my brain going, okay? So this right here is the same as negative infinity is less than x is less than infinity. And you could put this if you wanted to, and it will be completely correct. What I'm hoping that you will do, though, is that you will say that x is an element of all real numbers. This is the same as this notation here. And we talked about this in class. If you have like negative 5 is less than x is less than infinity, I didn't want you writing this part. I'd rather you just write x is greater than negative 5. Okay, so when you have a number and then infinity, I didn't want you writing the infinity. But if you have 2 infinities, that's okay. You could have written that right here if you wanted to, by putting negative infinity is less than x is less than positive infinity. Either one of these two notations right here is correct. But again, I would prefer you use this one, okay? And let me go ahead and read it as I go through it. It's the domain of all x's such that x is an element of all the real numbers, okay? And this element, it almost looks like a capital C with just a line that goes straight to the right. Okay, so just a fancy way of saying the x is an element of all the real numbers. Basically, AKA all real numbers. All right, so let's go ahead and go to the range. So the range, again, I'm going to use interval notation just to get my brain wrapped around, what am I looking at? And from the lowest y value, we're going to use a horizontal line. We're going to go from bottom to top. And as we're scanning this metal detector, like we said in class, aka we're gonna start at like a negative infinity for a y value. It starts way down here, way at negative infinity. And it'll go all the way up and stop because this right here is a closed dot. Okay, we're to assume it's a closed dot unless it specifically is drawn as being open. Okay, so just the way it is closed. So we're going to close it at 3. Okay, so again, negative infinity, some people might write it like this, and it is y because it's the range, and then less than or equal to 3. Please do not do this like I just said over here. If it's infinity and infinity, yes, you can. But if it's a number in infinity, I don't want you including this. I just want you to say y's that are less than or equal to 3, and then close the brace. Okay, so your final answer for this in set notation will be these two pieces right here that I'm boxing. All right, so let's go ahead and move down. We have 23 through 25 left. Let me make some room, do a little bit of erasing, and let's go ahead and answer number 23. Number 23 says, I'm given two functions. I'm given f of x, and I'm also given g of x. Okay, so here's g of x. And all I want to do is take f of x and subtract g of x from it. Okay, so good use of parentheses. I'm going to have 4x minus 5. I need to remember these parentheses. It's just saying this huge piece, if you will. And then g of x is 6x minus 3. Again, in parentheses. The biggest reason why is because these negative mistakes occur if you don't use parentheses. I'm subtracting right here. So if I didn't use parentheses, I would have only applied the negative to this first one and not the second one. But in Algebra 1, we learned on with parentheses, we need to distribute onto both terms. So it becomes a negative 6x. And then a negative times a negative is a positive 3. Okay? The first part stayed the same. That's still 4x minus 5. And then now from here, when we got rid of parentheses, we can get our terms together. We can combine like terms. So a positive 4 and a negative 6 become negative 2x, and a negative 5 and a positive 3 become a negative 2. And again, this is the answer that we're going to have from f of x minus g of x. And I want you to write it just like that and box the whole thing on the test. All right, so now let's go to number 24, and I'm going to do that down here. I'm going to take this new f of x, and I'm going to take this new g of x, and what I'm going to do is I'm going to multiply them together. That is not a composition. This is not the same as this, okay? This is multiplication, which is f of x times g of x. Whoops. Whereas this, f of g of x, is the same as f of g of x. That composition where it's a two-step process, okay? This, you are solving the answers to two different functions, and then you're just multiplying them together. All right, so let's go to find f of x. Well, there it is. It's given to us. We're going to take 4x plus 7 in parentheses, and we're going to multiply with g of x. And again, good use of parentheses. If I don't use parentheses here, I would only end up distributing this negative 5 onto both of these terms. But if I do it like this, it forces me to do a FOIL method. The first, the outside terms, the inside terms, and then the last terms. So let's go ahead and go through it. 4 times negative 5 is a negative 20x squared, because there's two x's multiplying together. And then the outside term becomes positive 4 and a positive 2 is a positive 8x. The inside is a positive 7 and a negative 5, which will give me a negative 35x, because I'm multiplying. And then 7 and a 2 will give me a positive 14. All right, so combining like terms from here, we're going to write our biggest power of x first, and then just go down from there. So a positive 8 minus 35, you could do 35 minus 8 over here off to the side. We get 20. We get 27. but it's a negative because it was a much bigger negative number. So we'll say a negative 27x plus 14. Again, on the test, we want you to write, this is f times g, and then we'll put x here. So parentheses, f times g of x is equal to all of this right here, negative 20x squared minus 27x plus 14. All right, last but not least, we're going to do this division problem on number 25. Okay, so let me go ahead and make a little bit of room. Scroll down. Actually, I'll just do it down here at the very bottom. So we're going to take this f of x right here, and we're going to take this g of x. We're going to divide them this time. So let's go ahead and put f of x on top. So we have 3x minus 6. We can put parentheses if we like. And we're going to divide it by x minus 2. Okay? And we could put parentheses if we like right there too. Now what I'm going to do here is, you notice when I'm dividing, like if I have 2/3 or let's say 2/20ths or 5/30ths, I'm always trying to reduce. Like this I can't reduce because they don't have anything in common. There's no greatest common factor. But here I can reduce by a factor of 2. So I could divide the top by 2, I could divide the bottom by 2, and I would reduce it to 1/10. And here the greatest common factor is 5. Then I could divide the top by 5, I could divide the bottom by 5, and I could reduce it to its equivalent 1/6. That's kind of what I'm doing here on this last one on 25. I want a GCF. I want to find the greatest common factor on the top two terms. And I'm going to pull it out from this parentheses and write it down right here. Well, the biggest thing they both have in common is 3. And if I pull that out, it's basically dividing it by 3. So like this 3x would be divided by 3, where just x is left over. And this negative 6 would be divided by positive 3, where negative 2 would be left over. So this is the same as over here, only it's in factored form. I pulled out a 3 by dividing it out from both of them, okay? And if you wanted to check if you did that correctly, you could always redistribute and see, do I get 3x minus 6, which in this case you would. Okay, the denominator is still x minus 2. Nothing has changed with that. But you see right now, the reason why I took this GCF and I divided out this greatest common factor is because now this entire thing I can divide, aka reduce, to a form of 1. It's like x over x will reduce to a form of 1. 2 over 2 would reduce to a form of 1. This is the same with these two binomials. So all I would have left over would be 3, okay? So 3 is my final answer, and after all that work, I'm going to put f of x, so f divided by g of x would be equal to 3, and I could write it like that. If you wanted to write it like this, you could write it like this as well, and you could say that the answer reduced all to 3.